everyone and welcome back to Study Room. Now that I have taught you the entire chapter of mensurations, we have talked about volume, surface areas of different types of solids. Let us now go through a quick recap so that our concepts are all brushed up and we'll be able to solve more numerical problems. The very first thing that I taught you was the volume of a trapezium. So a trapezium is actually a four-sided figure, that is a quadrilateral, with two parallel sides and two non-parallel sides. So in case of trapezium, the area of trapezium will be half multiplied with the sum of the parallel sides multiplied with the perpendicular distance between the parallel sides. Next up, I taught you about rhombus. In a rhombus, all the sides are equal in length and the opposite sides were parallel. So in case of rhombus, the area of rhombus is equal to half multiplied with the product of the diagonals. If we have two diagonals D1 and D2, so the area of the rhombus will be half multiplied with D1 multiplied with D2. Then next we studied about the surface areas of different types of solids, and we concluded from there that the surface area of different types of solid is nothing but the sum of the areas of each of the faces. For example, if we have a cube in total has 6 faces. If we calculate the area of one face of a cube and multiply it with 6, it will give us the total surface area of the entire cube. Next up, in particular, we discussed about the surface area of a cuboid, a cube and a cylinder. If we have a cuboid whose length is L, breadth is B and height is H, then the total surface area of that cuboid will be equal to 2 times length breadth plus breadth height plus length height. Next up, we discuss the surface area of a cube. In a cube, we have 6 identical square faces. So, if each edge of a cube is represented by L, then the area of one square face will be L square. So, the entire total surface area of the 6 faces will be equal to 6L square. We talked about the surface area of a cylinder as well. In a cylinder, we have a circular face and then 2 identical circular faces on the top and the bottom. One is the curved surface and we have 2 identical circular faces on the top and the bottom. In order to calculate the total surface area, we have to add the surface areas of both of them. The surface area of this curved surface of a cylinder is 2 pi RH. And when we calculate the area of these circular portions of the top and bottom, it is pi r square each, which gives us 2 pi r square. So 2 pi r square added up with the curved surface area, that is 2 pi RH, gives us the total surface area. When we simplify it further, we get the ultimate formula for the total surface area of the cylinder as 2 pi r within brackets r plus h, where r is the radius of the cylinder and h is the height of the cylinder. The next thing we discussed after surface area was volume. Volume is nothing but the amount of space that is occupied by a particular object. If I take a cylinder and it is occupying, let's say, 100 centimeter cube, so 100 centimeter cube is the amount of space that the cylinder is occupying and it will be the volume of the cylinder. The very next thing that I taught you was to calculate directly the volume of a cuboid, a cube and a cylinder. In case of a cuboid, L, B and H are the dimensions of a cuboid. So in that case, the volume of the cuboid will be equal to length into breadth into height and the unit will always be cubic units. If it is meter, then it will be meter cube. If the lengths are in centimeter, it will be centimeter cube. Next, the volume of a cube, if each of the edges of the cube is given as L, will be L cube. The volume of the cylinder is pi r square h, where r is the radius of the cylinder and h is the height of the cylinder. Now, we even discussed about some of the important conversions, unit conversions that will be required in solving a lot of numerical problems related to mensuration. The first thing is 1 centimeter cube is equal to 1 milliliter. So whenever we have been given something in milliliter and we have to convert in centimeter, we will be using this sign convention. That is 1 centimeter cube is equal to 1 milliliter. The very next thing that I taught you was 1 liter conversion into centimeter. If we have to convert something that has been given in liters to centimeter, then we have to use this conversion. That is 1 liter is equal to 1000 centimeter cube. Now what if I have to calculate or convert liters to meter cube or meter cube to liters? So we need a direct formula for meter cube to liter as well. So the conversion for 1 meter cube is actually 10 lakh centimeter cubes, which is equal to 1000 liters. So these were the conventions of converting from one unit to the other unit, and these are all related to volume problems. In volume problems, you will be needing all these conversions, and I hope you will be able to solve all the problems. So that's all. Thank you.